Sir, start, sir.
Good morning and a warm welcome to one and all gathered here. I wholeheartedly welcome our principal sir, Dr. N. Anbuchelian, our HOD sir, Dr. P. Yelumalai, all our faculty members and students to this generic talk series organized by our R.M.D. Engineering College. It's my immense pleasure to welcome today's guest, Miss Vamsi Priyanka G, Senior Software Engineer, HCL Technologies, to deliver a lecture on Google BigQuery. As you know, a huge amount of data are continuously generated as well as maintained by different applications. Techniques like BigQuery, which can operate on large data sets, becomes essential. In this context, this session will be very helpful and fruitful to everyone present here. Before starting this program, I would like to call upon our head of the department, Dr. P. Yelumalai sir, to introduce the chief guest. Over to you, sir.
Thank you, sir. Thank you. Good morning, one and all present here. I would like to extend my warm welcome once again, Vamsi Priyanka. On behalf of management, principal, dean, HODs, and faculty members, on behalf of all, we welcome you once again. I thank once again accepting our invitation to give a technical talk today. So our busy schedule, Vamsi Priyanka accepted this. So let me give brief introduction about Vamsi Priyanka, her career summary. She is having 10 plus experience in designing ETL process, extraction, transformation, loading and developing, batch processing using talent data transition. Is experienced in complete software test cycle and software development life cycle. Analyzed source systems, staging area, fact and dimension tables in target area, data warehouse. Extensive knowledge in data warehouse concept like data mart, data cube, snowflake, schema, star schema, and top-up, bottom-up approaches. She is experienced developing jobs in talent data integration. She is experienced to create metadata for different database files and talent. And also, she is experienced using queries and testing RDBMS such as Oracle. She is a senior software engineer in HCL Technologies. So she has completed many projects and software projects in HCL Technologies. She is career growth. So presently she is doing Google project. So it is a client of the Google. Our tools BigQuery Cloud Composer. So our role is GCP data engineers. Duration of this project from June 22 till now. So our experience, 10 plus years experience in software field. Our education qualifications, both UG and PG in computer science engineering, completed JNTU Kakinada. So today we are having such a eminent person in software engineer. So we have proud to give the technical talk today. Thank you for this opportunity once again. Welcome you, ma'am.
Thank you, sir. Thank you so much. Thank you for giving me this opportunity. Definitely, I will give my best. Thank you, sir. Thank you so much once again.
Yes.
Now I request Ms. Vamsi Priyanka madam to share his thoughts on Google BigQuery. Please, ma'am.
Okay, sir. Thank you. So, hi, welcome to one and all. Today, I am going to explain the Google Cloud Platform, one of the major leading cloud computing technology. In that, I am going to explain the one of the service that is the major service BigQuery. So, welcome to all. So, today's agenda, what is Google Cloud Platform? That is shortly we can say GCP, and why we are choosing GCP. And next, we are going to compare the GCP, Azure, and AWS. And next, services provided by the GCP. Introduction to Google Cloud BigQuery. Next, features of BigQuery. Working with BigQuery. Real-time POC. BigQuery AI relationship. And at last, we are ended with reference. So, what is Google Cloud Platform? So, we can Google Cloud, we can say this is the Google Cloud platform symbol. So it is the combination of all the services. We can do the end-to-end part in Google Cloud only. So what is GCP? Google Cloud Platform offered by Google is the suite of cloud computing service that run the same infrastructure Google uses internally for its end user products such as Google Search, Gmail, Google Drive, and YouTube also. So here what I'm trying to say, Google Cloud Platform itself giving all the services needed by the company, itself giving all the services. Internally, it is generally we are using daily we are using Google Search, Gmail, Google Drive. All these are running on Google Cloud services only. So for their internal products also, Google is using GCP services only. So we can modernize our apps and services on Google Cloud scalable infrastructure. So here scalable means we can measure the storage and we can extend the storage, and according to our requirements, we can design the services using the Google Cloud services. So Google Cloud services are very reliable and high performance cloud services. GCP provides a series of modular cloud services, including cloud computing, data storage, data analytics, and machine learning. So if we will choose Google Cloud as our cloud computing service, itself only giving the data storage capacity, and we can analyze the data in itself GCP, and we can go through the advanced topics like machine learning, artificial intelligence, etc. So introduction to GCP. Google Cloud Platform enables developers to build, test, deploy applications on Google's highly scalable and reliable infrastructure, from computing storage and application services from your web, mobile, and backend solutions. So here, if one person chooses the Google Cloud, so he don't want to go out of the Google Cloud. So he can build the application in the Google Cloud, he can test in the Google Cloud, and he can deploy the same application within Google Cloud also. So it is providing highly scalable and reliable infrastructure. So the major advantage in Google Cloud is, so it is highly scalable. If our data is how much it is, we can ignore, we can easily choose the Google Cloud services. Later, I will explain how we can scalable information, has reliable infrastructure. Later slides, I will explain. Google Cloud Platform is the set of modular cloud-based services that allow to creating anything from simple to complex applications. In Google Cloud, we can build the simple application as well as complex application. We can add so many features and so many advantages, so many artificial intelligence services to our applications through Google Cloud. These services resources are categorized as global, regional, and zonal resources. So in market, we have so many cloud computing technologies like Azure and AWS and GCP. Then why we are choosing GCP? So it runs on Google's infrastructure. Performance you can count upon means, so if we will choose any technology, any cloud computing technology, we may face some issues with that services. Means we can choose the storage and we can go for the artificial intelligence for other technology, and we can go for data analytics part for other technology. But in Google Cloud Platform, we can do everything in Google infrastructure only. It will provide everything end to end. That means runs on Google's infrastructure. Performance we can count upon. Costs. Google Cloud is clear winner when it comes to compute storage costs compared to AWS. So cost wise also it provides other compared to AWS and Azure. Cost wise also Google Cloud provide much cheaper cost. Market, AWS is the market leader when compared with AWS in terms of VM size. GCP now offers largest VMs in the market. Previously, AWS is the market leader. So I'm also agree with that. But now GCP offers largest VMs. VMs means here virtual machine. So GCP offers largest virtual machines in the market, is fast boot ups. So to any resources we can give the fast boot up. As per Grantor survey, GCP has the better UI features also. So these are the reasons we are using the GCP. One is infrastructure, other one is performance, and other one is cost. So last one is virtual machine boot up. So Google Cloud Platform lets you focus on what's next to your business. Google Cloud Platform frees you from the overhead of managing infrastructure, provisioning services, configuring networks, to let the innovator coders just code. So here the mean of overheading of other managing infrastructure means, so if we want to run the any application or build any application, we were not worried about the how we will manage the infrastructure, how many computers we have to purchase, our servers, how we'll configure the networks. All these headaches Google won't give us. So if we can clearly say to Google, this is our application. If we want to create and build and test and deploy this application, we can easily open the Google Cloud Platform and we can develop our application and deploy our application. Don't want to think about the networking connections, servers, and everything, infrastructure, everything it will provide easy to easy. So we can give our best to our application, future-proof infrastructure. So it is very secured one, globally it is very demanding cloud technology, high performance and cost effective also, and constantly improving. Seriously powerful data and analytics. Google Cloud itself. So once we build application, at last we want to analyze our data. So in Google Cloud only, it provides the analytics part also, so that we can analyze the data and we can estimate our how business is going on. So we based on the analytics part. No operations, just code. So if anyone from developing side also, don't think more about the connections part, operations, operating system part. Just we can open the Google Cloud Platform environment and we can start the coding of our application. So this is the Google Cloud, small pic of the Google Cloud data center. So for past 15 years, Google has been building out the fastest, most powerful, highest quality cloud infrastructure on the planet. So daily we are using the Google, how fast it will give the data for our questions or queries. So this is the one of the Google Cloud data center. So in this data center, we will store our data. Google Cloud infrastructure is built on the same familiarity that returns billions of search results in milliseconds. If we will give the any query to the Google, it will give the answer in milliseconds. Why means they are managing this much of data centers across the world. So that's why only they are giving that much fastest reply to our queries through Google search engine. Why Google Cloud Platform? So it is ability to build, organize, and operate huge network of servers on fiber optic cables with an efficiency speed that rocks physics on its heels. So worldwide, Google has so many data centers. It has huge network of servers and fiber optic cables. That's why Google daily we can use we are using Google, and it is the leading Google's search engine from last 15 years. No one can beat the Google because it is maintaining worldwide servers and fiber optic cables for quick response. So comparison of here, we can compare the Google Cloud and AWS, how virtual missions, how higher rights we can see here. Red color indicates that is AWS part and brown color indicates is Google Cloud part. See here, minimum and maximum boot times are measured in seconds. Google gives very takes very less time to give the answers, means give the queries, answers to our queries, means here, see here, minimum VM fast boot and higher writes. So read write spreads are measured in MBs, higher numbers means faster throughput. So here higher writes means Google give very higher, in within milliseconds also it give the reply to our inputs. So network speed also, bandwidth also very high to compare to AWS, and latency speed also very, latency means how much time it will take to give our answer to our question. So Google Cloud takes very less time to give a response to our question. When compared to AWS, it's very low. That's why we are, one of the reason we are choosing the Google Cloud. So pricing, coming to pricing rates, so AWS and Google Cloud very less expensive than AWS. We can give a very less cost for Google Cloud. So these are the data centers worldwide Google provides. So America, South Carolina, some of the Oregon, California, and some Asia also there are Singapore, Taiwan, they have data centers, and Europe also, Finland, Belgium, Ireland, they have so many data centers across the worldwide. So why Google Cloud Platform? One more reason is there, see here, we have so many data centers in the Google worldwide. So they are internally connected with very strong network servers and highly fiber optic cables. That's why Google search engine is very fast. So some is green color indicates the new regions coming. So they are introducing new data centers and new regions they are introducing. Already brown. Yellow color indicates the already established data centers. So we can see Beijing, Tokyo, Singapore, Sydney, so many data centers across the world. So coming to our Google Cloud infrastructure. So Google Cloud infrastructure as a service, Google Cloud Compute Engine, platform as a service, Google Cloud App Engine, software as a service, Google Applications. These we can divide our Google Cloud Computing as a 3 areas: infrastructure as a service, platform as a service, software as a service. So comparison, some of the main benefits of GCP pricings are no hidden charges. Means, so if we are taking any other cloud, so if we are continuously subscribed for any other Azure or any other cloud, so there are some hidden charges are there. They didn't mention anything about the prices, but that continuously costing for our services. In Google, there are no hidden charges. Whatever we are using, we can pay for that only. Pay as you go means Google offers customer use now, pay later. How much you are using Google Cloud services, we can pay that much only. No termination fee. At last, you can use all the Google services. Later, you don't want to use any Google Cloud services. Google will not cost anything to the termination fee. So you can easily quit off from the Google Cloud. These are some of the comparisons between main leading technologies in the market, that is Google Cloud, AWS, and Azure. Google Cloud mainly uses computing engine as a Google Cloud for computing purpose. And coming to AWS, computing engine is EC2 we can call, and Azure we can call virtual machines. So in Google Cloud storage, it uses Google Cloud storage for storage purposes, and coming to AWS, we can say it as a Amazon S3. So in AWS, we are storing the storage is Amazon S3. So in buckets, we can say the data, we store the data. In Google Cloud, we can store the Google Cloud storage. So, and coming AWS also, data lakes, data storage also AWS. Coming to the cost, Google Cloud provides lowest price to the customers to bid over the cloud providers. AWS pricing is generally mean to have includable. So the overall pricing is little bit complex, AWS. So we can say compared to all other cloud technologies, little bit lowest from Google Cloud. So next, services provided by the GCP. These are the main services provided by the GCP. One is compute, identity and security, networking, big data, storage and databases, and machine learning. So coming to the compute, we can compute our applications using these services. One is compute engine, app engine, container registry, cloud functions. Coming to security, cloud IAM, cloud resource manager, cloud security scanner, cloud platform security. Networking, cloud visual network, cloud balance, load balancing, cloud CDN, cloud interconnect, and cloud DNS. So big data. For big data, Google provides separate services. One is BigQuery, Cloud Data Flow, Cloud Data Prop, Cloud Data Lab. Storage also, storage, big table, cloud data storage, cloud SQL. So your machine learning have cloud machine learning, vision API, speech API. So many services are available. So now you get the one doubt here. So many services are there. How we can choose the better service as per our requirement. So here, for example, I am using the big data technology in our company. So I'm choosing which is big data related services provided by the Google Cloud. Here, big data related, Google Cloud provides BigQuery, Cloud Data Flow, Cloud Data Prop, Cloud Data Lab, and Cloud Composer also. So among these all services, how can I choose the best one? So here also we can choose our depends on data. So our data is stored in tables and everything very well managed, and our data is little bit low means we can go for cloud data flow. Our data is very big, large data. It's have terabytes, gigabytes of data. We can go for BigQuery. Depends on our data, incoming data, streaming data. Depends on that, we can choose the services from the big data section. Means from the big data services, we can choose the data. Same as here, storage and databases also there. Cloud storage is generally used for the storing general files like CSV files, XML files, JSON files. Cloud big table means very big tables, relational tables. If we have that type of data, we can choose the cloud big table. Cloud SQL means our database is relational database, means RDBMS. We can choose the cloud SQL. So depends on our requirement, what type of data we have, we can choose the services from the Google Cloud. And coming to the machine learning, this is very emerging service from the Google Cloud. So cloud machine learning is the one of the services provided by the Google Cloud, and it has also variety of services, that is vision API, speech API, natural language API, translation API, jobs API. Depending on our requirement, we can choose the services from the Google Cloud. This is also. So some management tools are also there. Stack drive, monitor, logging. So who are interested, so they can learn this service and they can work. So for developers also, there are some tools are there, that is Cloud SDK, the deployment manager, cloud source code for repositories and Android Studio. So these are the PowerShell for PowerShell users, Visual Studio. So there are so many tools are there. If you know about the .NET, there is separate service. If you know about the Java, there is separate services for them. For everyone, Google provide the easy code and easy develop and easy test and easy deploy. We can easily do the coding part and deployment part also. So big data. So here today we are mainly focusing on the big data. Who are working on the big data? This is called data engineers. Data engineers mainly working on the data. So they are working on data coming from the different type of inputs like streaming data, data coming from mobiles, data coming from the internet, data coming from some storage tables. So depending on the data input, we are working on the different type of services. Here data engineers works mostly, they are loading the data, transform the data, and finally they are again load the data into table where the destination company wants. Here BigQuery, Cloud Data Flow, Cloud Data Prop, Cloud Data Lab, Cloud PubSub. BigQuery only very fast service it is related to SQL queries. And one more example we can take Cloud PubSub. It is mainly used when the data is coming from the streaming, means data is coming from the mobiles and internet. Then we can choose the Cloud PubSub services. Dataproc, when any client wants any Spark and Hadoop services, then we go with Cloud Dataproc service. No, if you have both CSV files and in streaming data and combination of data you have, then you go with Cloud Data Flow. So different types of cloud storages are there in Google Cloud. Cloud storage, nearline, Cloud SQL depends on our data. SQL, if we have SQL data, means a table type of data, we can go with Cloud SQL. So compute, networking, virtual networking, cloud internet connect, cloud DNS, so many networking services, depends on our network types. Services, cloud machine learning, Vision API already we discussed. So key features of GCP. So on-demand services, so we can customize our requirement services through GCP. So automated environment we can customize. We can depends on our requirement. We can customize our application through GCP. Broad network access. One of the main reason is it has worldwide broad network access. That's why it's very fast. Resource pooling, rapid elasticity. Suddenly, if we got the terabytes of data, so Google provide that much storage capability for our data. So if we suddenly rapid elasticity, so some other cloud technologies may not give that much rapid elasticity, but Google provide because of its worldwide data centers and networking technology. Measured services, easy to pay feature is available on Google Cloud. Google Cloud pricing, 15% list prices difference, 24% sustained usage discounts it is giving now. So when comparing GCP with other leading competitors, it is benefits over them. Google provides its user and massive savings and including these discounts. Most companies, why choosing GCP means its capacity, it's providing huge capacity for our data, providing very multi-level security for our data. It has global infrastructure for networking. It supports bandwidth. Means if we have any doubts in Google Cloud, it supports with the skilled professionals already trained in GCP. If we have any doubt, we can directly call to call center or Google Cloud support center. They have skilled professionals. They will easily guide how to install, how to maintain everything. They will provide support. Facilities wise also the infrastructure components including physical equipment, everything they will provide. Transform data into actions. Here we can see how data goes in companies. See here, mobile apps, web apps, sensors, device, data is coming. Here, data ingestion means logs, measuring, everything. We are ingested the data. And here, next part is data preparation and processing. Means once data is coming, we are preparing data and stream processing, batch processing. Data preparation means we have three types of data mainly: structured data, and semi-structured data, unstructured data. Structured data means tables and Excel files. We have that one, we can call it as a structured data. Unstructured data, we have JSON files. And unstructured data means we have streaming data. Semi-structured means JSON files. So these type of data are there. We are processing the data and prepared the data in different types. That is data streaming processing, batch processing. So databases are relational. In that key file, document, white column, SQL, different databases are there, and we can go for the storage finally. And then on that data, we are exploring the data, and finally we are giving visualization to the data. And last part is analytics part. Means once we prepared the data, everything very neatly and tabular form, we are giving the data visualizations for the business purposes. And lastly, we can go for the artificial intelligence with the help of analytics. So here, stage-wise, which services we can use, we can see here. So data is coming here, mobile apps, web apps, sensor devices. For data ingestion, here I am taking the example services, not all services. For data ingestion from Google Cloud, we can use App Engine and Cloud PubSub. So as I mentioned earlier, for streaming data, we can take Cloud PubSub. For other data, we can take App Engine. And then we can go for the data preparation and processing. We can take services Cloud Data Flow and Dataproc. These are the example services. We may take many of the services from the Google Cloud as per our requirement. But here I am taking Cloud Data Flow and Dataproc. Once we are taking the data, we are doing some operations on the data. Means as per our requirement, if client wants anything on data, means if we want this date, we have this much of data. If as per a client requirement, we can modify our data. We will provide that data to client. See here, database and storage, Cloud SQL, Cloud Data Store, Cloud Bigtable, Cloud Storage. And exploration and collaboration, Cloud Data Lab, Cloud BigQuery, Cloud Dataproc, Google Analytics 360. These are the some of the services. And analytics part, Google BigQuery, Cloud Dataproc, Google Drive, and Analytics. And lastly, advanced analytics and intelligence, Cloud Machine Learning, Speech API, Vision API, Translate API. So here data flows from end to end. First data is coming and we are storing somewhere, and after storing, we are doing some operations on that data. Means as per client requirement. Once operations and transformations over, we are again giving to the client as per client requirement through some services like storage services. And then we are doing some operations like collaborations using some of the data, Cloud Dataproc, BigQuery services. Finally, we are doing some analytics part also. Analytics means, for example, in this year, client may go high growth. Last year, it may low growth. So how client can identify that means visualizations only. So for visualization part also, Google Cloud providing. So we can do, and here we can see the end-to-end part. Data is coming, how it is going. So one of the reason I am choosing Google Cloud BigQuery means it is mostly related to SQL. Who knows SQL very well, so we can easily do the BigQuery services. And it is also within Google Cloud BigQuery, we can do everything. So BigQuery is Google's fully managed petabyte scale, low cost and data warehouse. It is act as a like data warehouse and fully managed service. So BigQuery is a Google's fully managed petabyte scale, low cost analytics data warehouse. BigQuery is no operations, there is no infrastructure to manage, and you don't need to database and administrator. Generally, when we are using any database, we need some database administrator to give some access and to give some permissions. But when we are using the Google Cloud BigQuery, there is no need of database administrator. We can directly open the Google Cloud environment and we can directly use the Google Cloud BigQuery service. Why it is very popular nowadays, Google Cloud BigQuery means it scans the terabytes data in seconds. Terabytes of data in seconds. And it is using the SQL queries. So SQL queries it is using, and it using the REST web UI ODBC APIs also. That's why it's become very popular. So here you can see the Google Cloud new query environment, how it is running. So when we are writing any new query, we can run here, right here, and we can run the query. And bottom we can see the results and explanation. What are the errors, how it coming, how much time it will take, everything it will show the Google Cloud BigQuery environment. So this is the Google Cloud BigQuery environment. You can see in left side, we can see the how it stores the data, means table wise, and demo query we can see we can write the query here and run that query. Once we can run that query, it give the results and new query explanation. So it will only give the explanation part also. See here how much time that query will take the time to take the run, and then how much time it take to read the query, how much time it will take to compute, how much time it will take write, and everything it will give below the query part. Once we run the query, it will give every information about the query. So Google Cloud BigQuery, you can, when we will compare to Hadoop, Hive Technologies, Amazon Redshift, and Google Cloud BigQuery, it will give the 1.4 terabytes of data in milliseconds, 8 to 10 seconds. On average, it's within 8 to 10 seconds. That's why Google Cloud BigQuery is very popular nowadays. So here project hierarchy. So when we have project, all data in BigQuery belongs to inside the project. See BigQuery, first is the main topmost object is project. Under the project, we have data sets, tables, and job. See here holds one more data sets, means one or more tables. It's a combination of tables, as you know, like, so BigQuery is a combination of data sets. In data sets, we have different types of tables. Job means used to start potentially long running queries. If we have any big queries, means long running queries, we can do it as a jobs. So that's jobs already running in within BigQuery only. How we can access the BigQuery in Google Cloud? BigQuery web browser. So directly we can open a Google Cloud platform, and in Google Cloud platform we can see the BigQuery service. Once we will open the BigQuery service, it will give the command line prompt. Once we will enter the command line prompt, what are our requirements, it will directly take to Google Cloud BigQuery part. So BigQuery imports and exports the data, runs and queries. BigQuery command line, we can access the BigQuery in two types, or we can say it is mainly two types. Through service APIs also we can use the BigQuery, but it is compared to command line and BigQuery web browser, it is a little bit taking long time. So when we can access the BigQuery in mainly three types, but easy way is BigQuery. We can use the web browser, we can access the BigQuery, and one more thing is command line prompt. Command line tool, through the command line tool also we can access the BigQuery. And the rest of full API access BigQuery programmatically we can use, but it will take a long time. So there are so many third-party tools also available. Means if we for example, SQL Stream, Talent, Pervasive Informatica, and visualization tools also, ClickView, Power BI, Tableau, BIM. So many third-party tools also available. So from whatever the tool we have, we can get the data from the different tools. We can load into the BigQuery. We don't want any worry about what are the tools we have. From any third party tool, BigQuery we can load into the BigQuery. Loading data using the web browser. So how we can load the data using web browser? Upload from local disk from Google Cloud Storage, start the web browser, select dataset, create table, and follow the wizard steps. I will show you lastly how Google Cloud BigQuery is. So once you will open the web browser, so we can load our data into cloud storage, and then from cloud storage, we can load the data into BigQuery. Previously, we mentioned about the web browser. Now we are discussing about the command line using VQ tool. If we don't want to use the web browser, then you can open the command line and then enter this command. It will directly take to you into the BigQuery. So if not specified, the default file format is CSV. The files can also use new line delimited JSON format, and data source may be local machine or cloud storage. We can load the data from our local machine or on cloud storage. Anyway, we can load the data into BigQuery. Before we are loading into, there are some steps. We can follow that steps and we can use the BigQuery. So load limitations are there. 1000 import jobs per table per day. In BigQuery, we can import the 1000 import jobs per table per day and 10,000 import jobs per project per day. Earlier we discussed in BigQuery, there is some objects like project, table, jobs. So here I'm explaining how many jobs we can import per table per day, per project per day. So file size must be 1 GB for compressed file, 1 TB for uncompressed. So 10,000 files per import job. So once we import any job to BigQuery, 10,000 at a time, we can load the 10,000 files. And we can data measure as we can say it is a 1 TB per import job. So here we will say about the features of BigQuery. BigQuery is very fast serverless data warehouse. Here means serverless means we don't want any physical server to maintain the BigQuery. It is a serverless data warehouse. See here I'm explaining BigQuery is a serverless data warehouse and it is act like as a ETL tool, and it is giving the data analytics part also. It is giving the machine learning part also. So within BigQuery, we can do as per our requirement, everything. It is very fast, serverless data warehouse, and designed for particularly for the organizations who are having very high amount of data. For those organizations, so for that organizations only BigQuery designed. From getting detailed insights from data using built-in machine learning and analyzing petabytes of data using ANSI SQL, BigQuery offers wide variety of features, cost-effective pricing model. Here we look at some of those features. Okay. Multi-cloud functionality. BigQuery is an analytics solution that allows data analysis across multiple cloud platforms. So BigQuery takes the data from different cloud platforms also, not only within BigQuery, not only from our on-premises machine, it will take the data from the different other cloud technologies also. So way of analyzing data present in more one cloud without costing arm and leg. This is the cost to other solutions where this always involved high aggressive migrate data from one source to other source. BigQuery achieves separating compute and storage components. This means BigQuery can run the computation on the data right when located without the need for moving to different zone processing. This means when we are storing the computing and storage the data, BigQuery runs different means. For example, here nearby we have one data center. If we load the BigQuery on the now in Asia, it won't take much time because it has worldwide data centers. That's why if we load any data into BigQuery, immediately we can compute the data and store the data within seconds, because it provides the multiple zones and data centers worldwide, and storage and computing components also different. We don't go for here, we can do the computing processes. For storing purpose, we can go for other cloud platform. We don't want here. Everything we can do here only. Storage we can do in BigQuery, and computing part on that data also we can do within BigQuery. So built-in ML integration. BigQuery provides not only computing and storage, BigQuery provides machine learning part also. Use it for creating and executing machine learning models in BigQuery using simple SQL queries. Why it becomes most popular means we can achieve our machine learning part using simple SQL queries. If you know very much about SQL end-to-end, we can choose BigQuery and we can practice, or we can create multiple jobs for machine learning. Prior to the introduction to the BigQuery, Machine learning on large data sets required ML specific knowledge programming skills. When we are choosing BigQuery machine learning part, we know some required ML specific knowledge and very low programming skills and machine learning specific knowledge. If you know, we can choose the BigQuery for our ML purpose, machine learning purpose. BigQuery ML eliminated the need of for that, allowing SQL practitioners building ML models using their existing skills. For example, so many people are thinking if you know very much programming knowledge only, then only we can choose the machine learning part. Otherwise, we can't do machine learning part. No, that is not the real case in BigQuery. If you know very little bit of programming skills and much knowledge on SQL and little bit ML specific knowledge, machine learning specific knowledge, some terminologies are there. No? So if we know all these three, we can go for the machine learning part in BigQuery. BigQuery ML can be accessed in the following four manners: Google Cloud Console, BigQuery command line tool, BigQuery REST API, and external tool, for example, Jupyter. So here I'm explaining. You can ask like how we can use the machine learning in BigQuery. In four ways we can use. One is Google Cloud Console. Directly we can open the Google Cloud and we can use the Google Cloud BigQuery machine learning part. Otherwise, we can use the BigQuery command line tool. Otherwise, we can use BigQuery REST API. At last, we can use our Jupyter notebooks. From that also, we can use the we can enter the BigQuery machine learning part. Foundation for BI. So up to now, what we discussed, why BigQuery became most popular because of its features. If you know SQL knowledge, we can use BigQuery, and it provides the data warehouse features, ETL features, and then machine learning features. Now BI features means once we load the data into BigQuery and we will do some operations in the BigQuery and we will do some machine learning part also within BigQuery. Now we are coming some business intelligence purpose also we can do within BigQuery. BigQuery BI engine is a memory analysis solution. It is used to analyze the data stored in BigQuery with high concurrency and response times of under a second. This helps to interact with other BI tools like Looker, Tableau, Power BI. Can also integrate with custom applications, help the data exploration and analysis. Means we can use the analysis part in the BigQuery. This helps to how it will help. Means we can use the other BI tools or other BI tools also there in market, that is Looker, Tableau, Power BI. We can use these BI tools also for our purpose. But why we are using BigQuery means it will give business intelligence very high concurrency. Response time is also very less. Within seconds it will give. That's why we are choosing the BigQuery BI engine part. So once we are using BigQuery BI engine part, it will help us to explore the other BI tools like Power BI and extra. It is very speed, simplicity, very fast response times and load times with the help of data analysis and power streaming. For streaming data also, data is continuously coming. On that data also, we can perform some business intelligence operations with using of Power BigQuery. So it is very simple to use. Once you open the BigQuery now, so it's very easy to very simply we can use the analysis part in the BigQuery. Ease of use. There is the smart cloning design ensures that very few configuration settings are only required to use the business intelligence task in the BigQuery. Geospatial analysis. BigQuery Geographic Information Systems provides information about location and mapping, which is important data warehouse like BigQuery. So it is also provides the geographic information like location and mapping also. BigQuery JS function by converting latitude and longitude columns into geographical points. So daily we are using our Google Maps. So Google Maps also using BigQuery. So geometry, spatial feature collection. This is this represents an area of surface on the earth Spatial feature means this represents logical spatial object. Spatial feature collection means this is a set of spatial features. So Google Maps using some of the geographical points. Through this, we can achieve our data accessing time. In very low time, we can access the data. Automated data transfer. So we don't want to write any code for the transfer the data from one source to other source. It automatically, if one click, it will give the one source to destination, it will transfer the data. That is called automated data transfer in BigQuery. BigQuery data transfer is a service that automates the movement of data into BigQuery on a regular basis. This schedule can be managed by the analytics team by simple manner without need any coding. Also add data backfills to make up every gaps of outage of during ingestion. It will move the data from one source to other source. If we are loading data from different inputs to BigQuery, we don't want to write any coding or any jobs. Simply, it has already pre-built steps. If we will click on that pre-built steps, we can load the data into the BigQuery. All these steps are data analytic teams will look over these data transfer part. In companies, data analytics team will look over the data transferring part in the BigQuery. The BigQuery data transfer service can be accessed in 3 ways. Cloud, here also same. Cloud Console, BigQuery command line tool, BigQuery data transfer API service. So here while all the features of BigQuery mentioned above were very useful, sometimes might want to more experience with set features before. So earlier I explained so many features are there. So for BigQuery sandbox also coming with set of limitations that are applicable until the upgrade. So all BigQuery quotas or limits are applicable when we are opening the Google Cloud environment. If you will subscribe, it will give you 60 days of free trial. You can practice any service from the Google Cloud with some limitations. It will not provide all the features, but it will provide some features with 60 days of free trial. Working with BigQuery, how we can see divided into 3 main parts. So as earlier I said, ingestion part, storage part, preparation part, and analysis part. So here we can ingest the data like this. Google Cloud, cloud storage, sheets, databases, applications, files. We can ingest the data into BigQuery, and later coming on that data, we can do some operations and refining the data. Refining the data means as per our requirement, we can modify the data as per our requirement. After that, again, we can load into the BigQuery, already transformed the refined data, again loading into the BigQuery cloud storage. Here you can see. And finally, that BigQuery, we can load that data into analysis part and ML part. See here, in this entire flow of data, you can see everywhere BigQuery. For ingestion also, you are seeing BigQuery. Preparation of data and storage also, you can see the BigQuery, and analysis and ML part also BigQuery you can see. Because that's why I'm saying everything we can do within BigQuery. This is the flow of data. Generally in companies, this is the flow of data. They are ingesting data, preparing the data, and storage the data. Again, they will send to analysis part and ML part. So prerequisite, what are the prerequisites for working with BigQuery? So we have to create the table, listing all tables in data set. Once we will open the Google Cloud environment, you can see all these, how we will create the metadata. Once the table is created, what are the further steps? It will give everything step by step information and guide. Within Google Cloud platform only, they will provide everything step by step. So first we will ingest it, as earlier I said, first ingest the data using, we can ingest the data from within Google Cloud, streaming, or from any input or streaming or a third party application we can ingest and prepare. Second part, we are preparing and storage. And third part, analysis. So maximum 1 GB per file. The available options are here: either manually export the data to a service like data flow. So many services are there. We can use the services for analysis and export. Once process the data, we can export the data into different tools. So one real-time POC here I'm showing that this is the how once you open the big Google Cloud platform, you can see the BigQuery like this. This is the BigQuery visual part in the Google Cloud platform. So this is query history, saved queries, job history, transfer, schedule queries, BI engine, everything earlier I said you can see here, and you can add data here, and you can run the query, and saved query, scheduled query, how much time it will take, everything we can see. See here the some here you can see BigQuery public data, everything BigQuery stored as a tables. Like Austin 311 is one table, Austin bike example I am saying Austin bike share is one more table. Everything it is storing under the tables, data sets and tables. Data set is a combination of tables. Here you can see the blocks, what is the field names, what is the type, string or integer, mode, everything it is clearly, we can see the everything in BigQuery. We can copy the table, delete the table, everything in who knows SQL very well, they can go for the BigQuery practice. Command line, earlier I said now, we can go through command line also. So BigQuery command line, using these commands, we can go to the BigQuery. BigQuery, finally, BigQuery AI relationship, how support data engineering, no need to export the data, use SQL. Just we know the SQL and some little bit machine learning part, BigQuery support the ML part also. We can create so many machine learning models in SQL, linear regression, clustering, matrix fractionalization, boosted tree and XGBoost, so many TensorFlow. These are the some terminologies regarding to machine learning. So we can achieve these machine learning techniques and models through BigQuery. I'm showing here example model, how we can create the example machine learning model using BigQuery. This is a small example. Create model, what are the steps? Model, first we have to choose the model type, input label columns, regularization, learning rate, early stop, standardized features, max tree depth, everything we can see. Example, how to evaluate that part, example predict. So this is the up to this we explained everything about that, how we can achieve the data storage, analysis part, computation part, machine learning part through we can achieve the BigQuery. This I showed some examples. So we can do some certifications also. Google provides some certifications: associate cloud engineer, data engineer, architect, Google Cloud architect also. So here if you want to practice any Google Cloud POCs, these two websites are very much helpful. That is medium.com and kaggle.com. If you go through these websites, they are providing multiple POCs, real-time POCs. Thank you very much. And one more, I will show you how if you want to practice any Google Cloud in future, if you have any free time, this is the one. So this is a Google Cloud Partner Cloud Skill Boost. You can note down Partner Cloud Skill Boost .google. Once you go through this link, Google provide everything about the Google Cloud services. Just you can enter your email ID and password. You can sign up, and in this you can explore everything. What is the service? How we can learn? They will provide learning material, guides, certifications, questions, answers, everything you can practice here. If you want to, if you have any free time, you can practice here. Thank you so much for this. Thank you for giving this time.
Thank you, madam. Thanks for your wonderful presentation. Now I would like to invite Dr. Rajalakshmi madam to propose vote of thanks. Please, ma'am.
Yes, sir. I, Dr. D. Rajalakshmi, would like to extend my heartfelt gratitude to Ms. Vamsi Priyanka, Senior Software Engineer, HCL Technologies, Chennai, for her insightful and enriching session on Google Cloud BigQuery. Her expertise and dedication have truly illuminated our understanding of this complex subject matter. I also wish to express my sincere appreciation to the management for their unwavering support in organizing such valuable learning opportunities for us. Without their continuous encouragement, events like these wouldn't be possible. A special thank you to our esteemed principal for fostering an environment that encourages innovation and learning. Your vision and guidance inspires us to reach new heights of excellence. I would also like to acknowledge the head of the department for his constant encouragement and guidance in promoting such informative sessions for the benefit of the students. To all the faculty members who have worked tirelessly behind the scene to make today's event a success, your dedication is truly commendable. And last but certainly not least, I extend my gratitude to all the students who actively participated and engaged in today's session. Your enthusiasm and eagerness to learn contribute significantly to the vibrant academic atmosphere of our institution. Once again, a big thank you to Ms. Vamsi Priyanka for sharing her knowledge with us. Let's continue to strive for excellence and embrace learning opportunities like these to broaden our horizons. Thank you.
Thank you, madam. Thank
Thank
you
you.
so
Thank you,
much.
ma'am.
Thank you, sir.
Thank you
Thank you,
all.
HOD sir, principal sir, and Srini sir, everybody. Thank you, students, for spending this much of time. Once again, thank you. Thank you so much, sir.
Thank you so much, ma'am.
Thank you. Thank you. Thank you.